Okay, let me start the session. Before that, I just want to check with you guys that are you ready for the preparation? If you are the first time learner, that is my own way to start the session. Always when we will be starting the session, I will be asking that you guys are ready for learning or not. If you guys are ready, I will be ready with highest level of energy and high level of enthusiasm to teach you guys with amazing kind of content. Now if you are ready, just give me thumbs up. Yes, you are ready. Type down in the comment box you are ready, and let's get started. All the members who are asking, sir, what will be the difference in your this data structure course from the previous one? Few questions I am adding, few explanations I am changing a bit, and few questions I am adding for your placement preparation. I will give you timely guidance that this type of questions can be asked in your placements. So this will be the difference from previous one to this one. This time I will be having this particular data structure course little longer than the previous one. 100% ready. So let's get started. What is the data structure? That is the simple definition I have written, but that simple definition is having very deep meaning. Mathematical and logical model of organizing the interrelated data. There are three keywords in this definition. What are the three keywords? These I underlined. First of all, let's talk about interrelated data. If you have one data structure in which you are storing or organizing some data, then of course the data should be interrelated somehow. Of course, then only that single data structure we will use to solve the problems. Mic issue? What is the issue? What is the issue? Sir, will you share the slides on Telegram group? Yes, of course I will share. Of course I will share. What is the problem in mic? Is that fine now? Is that fine now? Can you please check out? Is that fine now? Is this better now? The voice is better now. Can you please confirm? Still not clear? For placement, should I take plus subscription for competitive programming or GATE? Shravanti Patil. Do one thing. You can take a subscription which gives you combination. It will give you GATE also. It will give you the competitive programming subscription also. There is a combo. You can ask me. You can send a message me. Then I can share the link with you. So both you will be able to cover GATE also plus the placement competitive programming also. Okay, fine. Better now. Let's start the session. So in this particular definition, we have three different types of keywords. Interrelated data, of course, if we are taking one data structure, it should have some interrelated data in that. That's confirmed. Now two more remaining. Mathematical model and logical model. What is that? When we organize the data, sure, Kuldeep, definitely I will do that. When we organize the data, then how exactly we organize the data in a specific data structure? For that, we have one type of predefined structure. I will take an example here. If you are aware of Q data structure, in Q data structure, we have the FIFO kind of organization. The stack data structure has predefined manner of organizing the data. Yes. What is the manner? LIFO kind of structure. Means last in, first out. Whichever element you insert last should be deleted first. You have linked list. If you know about this, then in the linked list we have what? In the linked list we have linear order maintained through the pointers. So every data structure which we manage has some predefined organizational structure, and that is called as mathematical model of that data structure. So mathematical model means there is a predefined structure to organize the data. That is mathematical model. Now what is logical model? Logical model says that data structure is not only up to organization or only storage of the data. Data structure में सिर्फ storage नहीं आता है. We include something else also in data structure, and that is what? That is the basic operations which we can perform over the given data, over the organized data. So the operations also are included in data structure. So if you say data structure is given, we will give some organization, that how we will manage the, or how we will organize the data within the storage, and after that we will give some basic operations. Like if I say I have given you stack data structure, means I have given you organization LIFO type, plus I have given you two basic operations, push and pop. Right? So the name mathematical just because it is predefined and we cannot change it. Logical, why? Just because operations whichever we want we can keep. Along with push and pop you can have more functions on the stack. Of course your requirement, आपकी जरूरत पे आपको लगता है तो और functions ले लो. So operations on data will be included also along with the organization. That is why this logical model. Now the biggest question I will ask here is why data structure is needed? What is the use of data structure? Only organizing the data? Let's have a bigger picture of that. Let's have a bigger picture of that, why data structure is used. The bigger picture is we use the data structure to solve the problems. We have so many problems. I am not talking about your daily life problems. सर गड़ी नहीं आ रही है, इसने पानी नहीं भरा, खाना नहीं मिला, अच्छा खाना नहीं मिला, खाने में कीड़े मिले हॉस्टल में, multiple other problems you can have in your life. I am not bothered about it. I am talking about those computational or algorithmic problems which we as software engineers are facing in the software industry, IT industry. So if we have the computational problems or algorithmic problems, we need to solve those problems. But there is a star mark over there, condition applied. What is that condition applied? The condition applied is that if you want to solve a particular problem, the solution should be efficient. It should give you the answer, the result in very less time, minimal time. So if you are writing an algorithm, solving an algorithmic or computational problem by writing an algorithm, you need to select a data structure which is best suited for that algorithm. Now what is the meaning of best suited? Best suited means that data structure, if we are going to use to solve that algorithm, to solve that problem, to write that algorithm, I will have the best possible result through this algorithm with minimum time, minimum efforts, minimum space. I am summarizing this entire explanation that data structure is specifically properly selected so that a very specific kind of problem can be solved using writing the algorithm with minimum efforts, minimum complexities. Okay, understanding this, so I am writing a statement which will be very important for your entire life. Why? Just because this will be one of the biggest challenge for you in the ID industry. If you are going to use some algorithmic problem solution, if you wanna write using the data structure, then you are going to have this problem that which data structure should I choose here so that my problem can be solved very quickly within minimum time. So I am writing here, select a data structure which can help to solve a problem optimally. Optimally means we can achieve the solution with optimum solution. I hope you are understanding. That is why this particular data structure is very important part. It plays a very important part in your IT industry work. That is why for your placements, whether it is the first time or for your placements, if you are changing your job, whether you have 2 years experience or 5 years experience or 10 years experience, if you are going to work in software industry, this is the mandatory part to be asked, so that the interviewer can judge you. If you are good in data structures and related algorithmic problems, then of course you will be good enough to solve any kind of problems in the IT industry. Let's talk about two types of data structure. We have two types of data structure, linear and non-linear. Linear data structure we have, which are elements are arranged in the linear or sequential fashion. Can you give me example of this? What are the examples of this linear data structure? Examples are, of course, array, then linked list, and queue and stack. For non-linear data structures, we have examples. बोलो भाई, पता है? Do you know that? Tree, different types of tree, hierarchical model. The trees are having non-linearities, of course, the graphs and हैश टेबल. अब आप बोलोगे सर हैश टेबल तो सीक्वेंशियल दिखती है, क्या उसमें एलिमेंट्स हम सीक्वेंशियली अरेंज करते हैं हर बार? ना, हैश टेबल. Okay, now this is fine. Two types of data structures we have, basis of what type of arrangement we have for the elements. Do we arrange the elements in sequential order or non-sequential order? Based on that we have. Now we have classification also of data structure. And what does it mean? The meaning of classification is based on the usage of data structure, what type of data structure we can have. So there are three classes of data structure based on why a data structure is to be used. I am writing here why data structures is used. Based on that we have a classification of data structure. So the first class we have is container class. This particular container class data structures are used to only contain the elements, only storage. That's it. And in this container class we have examples like array and linked list. So these two are used only to store the elements. That's it. No any specific other usage. Then we have second class. The second class is priority queue class. Now what is the meaning of priority queue class? Priority queue class means we have a specific restriction on the deletion of elements. Insertion and deletion of the elements are having specific pattern. Like, let's talk about queue. In the queue, the very first inserted element only to be deleted next. We all know that. We all know that. What I'm saying is, in the queue, at very first, the first inserted element only to be deleted first. Very simple case, yes. That is priority queue class, yes. So we have a restriction over deletion, and that restriction is what? The restriction is the first element only to be deleted first, inserted element. Second, for the stack also we have priority of deletion. The last inserted element only can be deleted. For heap also we have such kind of deletion specification. Yes. So these are the example of priority class. Examples are what? Queue data structure. We have stack data structure. We have heap data structure. All these are having very specific priority class. Then we have indexing class. Indexing, you all know what is the meaning of indexing, right? Indexing पता है ना क्या होती है? Book number का indexing, playlist का indexing, multiple places you can have indexing. So for indexing class, what are the data structure which will be coming under this indexing class? Binary search tree we have, B tree we have, B plus tree we have, then hash tables we have. I don't know if I'm writing on my head itself. I can write it here. These are the data structures which are classified as index class, used for indexing purpose. Got it? Now, look at this. This is our syllabus, which I am going to teach this time. Now, if you have taken or if you have checked out my previous videos, in previous videos in the trees, I haven't taught you heaps. This time I'm going to cover this heaps also. For graph, this time I'm going to explain the graph beyond the BFS and DFS also. Few more algorithms, shortest path algorithms, and few more algorithms we are going to discuss along with their complexity analysis also in this particular syllabus. So of course we'll be having array. Lots of problems we're gonna solve from array. Then we'll be having linked list, then queue, then stack. In the stack we'll be having expressions and recursion, then tree, graph, and hashing. All these we will be covering in this specific order only. किसी ने पूछा है how is BST used for indexing? Vaibhav, do you know what is the meaning of BST, binary search tree? Right? If you know what is a BST, binary search tree, you can use it for indexing of the database elements. If suppose you have done the indexing on some kind of integer column in the databases, some values which are having less value of that column will go into the left side, greater value go to the right side. You know the BST property, you can understand indexing can be done easily. So all these graph related algorithms we are going to discuss, which are there in your syllabus for GATE. Not many things we are going to discuss, but certain things apart from whatever we have discussed in the last particular talk. Now let's discuss about this. What are the operations we can perform on the data structures? Sir, who will teach C programming, magnetic music? I will teach C programming this time on this channel, till if we have a new educator. Now listen, what are the operations? These are the basic operations which can be performed almost all the data structure. क्या सर हम हर एक डेटा स्ट्रक्चर पे ये परफॉर्म करेंगे? Will we perform these operations on each data structure? Almost on all data structures we are going to see these operations, and we will see how these operations are performed on different data structures, and based on that we will do some complexity analysis, we will do some algorithms and multiple other things we are going to discuss. But these operations you should be able to understand what is the meaning of this. First one is traversing. ट्रैवर्सिंग इज नथिंग बट जैसे कि आप लोग गेम खेलते हैं छुपम छुपाई का, इट्स लाइक अ हाइड एंड सी गेम. इफ यू आर ऑन द अदर साइड, ऑल द मेंबर्स आर hidden somewhere, you will have to find out each and every person one by one, and you need to touch each means you need to just say, okay, I have found this fellow, then this fellow, this fellow, this fellow, and bina bina dhappa hue. Okay, now the traversing is very simple. You have already a data structure. In that data structure, some elements are there. You need to visit each and every element of that data structure one time. So you need to perform some operation, whatever you want, one time. Minimum one time also, maximum one time also. That is traversing, visiting each and every element of data structure at least and at most once. That is traversing. Now let's go for this one. इंसर्शन सर्चिंग एंड ट्रैवर्सिंग में क्या डिफरेंस है सर? सर्चिंग का मतलब होता है कि यू हैव वन एलिमेंट गिवन एंड अ डेटा स्ट्रक्चर गिवन. In that data structure you are finding that particular element. I'm gonna explain that later on. Look at this. Wait, I'll explain that. Insertion means you have already a data structure with certain elements and you want to add one more element in that data structure. That is insertion. Now insertion may have a very specific type based on the data structure, that where to insert, how to insert, that is dependent on the data structure, type of data structure. But adding a new element in the data structure is insertion. While doing insertion, we may have one particular error, a runtime error. If you all know that name of the error, पता है किसी को? The error name is overflow. What is the meaning of this? What is the meaning of this? The meaning of this overflow is already data structure is there and it has maximum capacity of elements. More further, if you want to insert, data structure will deny, no, further element cannot be inserted because data structure is full. In that case, then an error message comes called as overflow. So overflow is, it's an error occurred when we are trying to insert an element in a data structure which is full, already full. Got it? Now let's talk about deletion. Deletion means you have a data structure. From that data structure we need to remove one element. That is one deletion. Now again, in this deletion also we may have a runtime error. You all know that, which is called as underflow. What is underflow? Underflow is the data structure is empty and we are trying to delete an element from here. There is no any element. How can you delete it? Element ही नहीं है, deletion कहाँ से होगा? Right? So underflow is the error when trying to delete from an empty data structure. Now look at this. These two conditions, overflow and underflow, these conditions you often face in your real life also. When you are studying during the classroom, overflow condition is very common. Sir, अब दिमाग पूरा भर गया, अब कुछ नया अंदर नहीं जा रहा है. But when we go for examination, the underflow condition comes into the picture. कि सर दिमाग में कुछ है ही नहीं तो बाहर क्या आएगा और क्या ही लिखेंगे हम. There is nothing in our mind. How can we bring out and we can write down in the exam? Underflow. Okay, let's come here. Searching. What is searching? Searching is finding an element in a data structure. So already one data structure is given to you and there is an element given to you. You need to find out that this element is present in this data structure or not. That is searching. Now somebody asks what is the difference between traversing and searching. It's very simple thing. Traversing means we don't have any element already given. We have entire data structure. We need to perform some operation on each element of data structure. Now finding an element means we have an element which we need to search in this the given data structure and we need to know that where this element is present in data structure. Now I'm asking a cross question to you guys. Can you tell me if you are performing a searching, suppose you have written a searching algorithm, then what will be the output of that searching algorithm? बहुत high level question है, but I hope you will be able to answer it. If suppose you are finding an element, you found that element, what will be the output you are going to return from that searching algorithm? And the output of the searching algorithm is what? Can somebody let me know? The output is nothing but the what? Location of element. Where this particular element is present, that location to be returned. Now, if we have क्या हुआ यार ये? हाँ यार आधी अधूरी आई है. Okay, if we have this particular searching, then it's very simple thing. We have searching ka outcome two types. Outcome of searching can be of two types. What are the two types? The types are very simple. Either the searching is successful or unsuccessful. Can somebody tell me what is the meaning of successful search and unsuccessful search? Successful means you have tried searching an element and you got the success. You are able to trace down that element, means the element is present in the data structure. The element is present in data structure. So if it's a successful search, I am writing the definition: element present in data structure. If element present in data structure, then what you are going to return? What you are going to return? What you are going to return? You are going to return the location where the element is present. Let's say if you are storing the elements in the array kind of data structure, then in that case, in successful search, you are going to return the index where the element is present. But if suppose you are going to store the element in linked list or tree kind of structure in which you store the element on the nodes, अगर आपको बेसिक पता है तो आपको समझ में आएगा, नहीं पता है तो इट्स फाइन, नो प्रॉब्लम. Whenever we will be studying the data structure like tree or linked list, you will understand. So in that particular case, what you are going to return? You are going to return, I should write it, return the address of the node. Return the address of the node wherever the element is present. Now, if suppose the search is unsuccessful, element not present, in that particular case, what is going to be returned when we are storing the elements in the array index like structure. In that case you will say sir -1 return करेंगे, but when you will say -1 you will return just because you know that the array are having starting index 0 in the specific programming languages. But it's not always the case, dear. We are not studying programming language here, we are studying the data structure here. In that particular case, the data structure, in data structure we can have array ka starting index 0 1 2 3 4 5 6, any integer value, in fact -10 -15 -18 also. So from which index we are starting the array ka indexing, that -1 we are going to return. Yes, so we are going to return lower bound -1, and what is LB here? LB is the starting index of array. In case of linked list or tree like data structure where we are storing the elements on the nodes, we are going to return null pointer. Address null pointer will give the information that element is not present, that's why we are returning null. Great, amazing. चलो समझ में आ रही है चीजें? आर यू गेटिंग इट? वेरी वेरी सिंपल, very very simple, very very simple. I am going with very very simple things today, but are you understanding? It's a very basic starting, but slowly when we will pick up the pace, and when we will go for the higher level of learning, you need to be along with me. आप लोग बोलते हो ना सर प्लस पे ऐसा क्या मिलता है जब YouTube पे नहीं मिलता? You always ask me that sir what you provide on Unacademy Plus which we don't get here on YouTube. Only one thing I don't get from your end, and which is your constant presence, the continuity. Yes, definitely Dipanjan, I will complete entire data structure here. The continuity of your presence, the consistency from your end. If you will be coming live here daily, I will be with highest level of energy present here. Full day, पूरा दिन से मैंने almost 6+ hours पढ़ा लिया है अभी तक. Still 2 meetings also I have completed. Still I am energetic just because you guys are present here. It's all up to you that if you give me a good response, I will give you a good content. It's a vice versa complementary process. I started fine, you give me the compliment with your presence, with your consistency, with your that hunger of learning, and I will be presenting you the best learning on this particular channel, on this particular lecture series, that's for sure. सब कुछ करवाएंगे, सब कुछ, पूरा कोर्स खत्म होगा एक एक चीज. इनफैक्ट साथ ही साथ एक बार और पीवाईक्यू की सीरीज भी लगा दूंगा. सारे पीवाईक्यू सॉल्व करेंगे एक बार यहीं पे. जो चाहिएगा वो मिलेगा, प्रैक्टिस सेशंस भी मिलेंगे, बहुत कुछ मिलेगा. जस्ट यू कम लाइव, दैट्स द ओनली थिंग विच वी वांट फ्रॉम योर एंड. दैट्स ग्रेट. चलिए ओके, नेक्स्ट वन, व्हाट इज लोअर बाउंड? लोअर बाउंड ये लिखा है ना, ये क्या है यहाँ पे? स्टार्टिंग इंडेक्स ऑफ एरे. स्टार्टिंग इंडेक्स ऑफ एरे कैन बी 0 1 2 3 व्हाटएवर. चलिए एल्गोरिथम पार्ट, Shravanti Patil, don't worry, once one course will be done, next few courses will be coming, and next courses will be coming. Don't worry about that. We will cover entire subject here. Everything we will be covering here. Okay, let's go further. What is merging? Merging is combining two data structure of same type into one. If we have two data structure of the same type, we will have to merge them into one type, and that is merging. Very simple thing. Okay, one more data structure function I haven't written here, that is the sorting, and I guess you guys can give me the definition. What is the sorting? Sorting क्या होता है? What is sorting? Can you give me the definition of this? Sorting is arranging the elements in ascending or descending order. That is sorting. Now, so many students question me at this moment, sir, should we apply all these functions on each and every data structure? Then I ask you a very simple thing, should we apply? शुड वी नीड इट, शुड वी रिक्वायर इट, क्या हमें जरूरत है? अगर है तो डेफिनेटली करेंगे, अगर नहीं है तो नहीं करेंगे. इट्स वेरी सिंपल प्रोसीजर. सो इफ I need to have a particular problem solved. During that problem, I need to merge two arrays into a single array. Then of course, I will apply the merging on that particular position. If I have two heaps and if I will have to merge two heaps into single one for some kind of problem solving, of course I can use merging over there. So all these are the basic operations which can be applied over almost all the data structures. But if we need that operation, very highly needed that data structure operation, then we will apply. Like in the array, insertion, deletion applied, yes. Searching applied, yes. Sorting applied, yes. Merging applied, yes. Linked list sorting applied, yes, we can do it. Merging, yes, we can do it. Insertion, deletion, of course we can do it. So whatever the operations required, that operation we will provide, otherwise not. Fine. Now what will be the course? This particular course will be organized in such a way, we will study the basics of each and every data structure. After that, we will go for some operations. Like if we will start from array, we will be checking out in the array how can we go for traversing, how can we go for insertion, how can we go for deletion, how can we go for merging, sorting, searching, and multiple other things. So slowly everything we will discuss about. Fine. Okay.